Hello! In this video, I'm going to be going through personal and public transport. I'm going to be going through the historical developments for transport. I'm going to be going through this really quickly, but I have a lot of students who are out at the moment, so and I don't know if I have a video on this. So we're going to be looking at two specific transport vehicles. We're going to be looking at bicycles and trains. We will talk very, very briefly about electric vehicles at the end. It is worth mentioning that there have been questions on electric vehicles, so I'm going to say that now so I don't forget it later. Okay, so first of all, we're going to be looking at bicycles. There are some bicycles. There's a bicycle was ridden around the Palais Royal, or Jardin du Palais Royal in Paris. It was a child's toy, but we're interested in, we mentioned sometimes the German Baron Karl von Drais, and he built something called the Laufs machine. Here it says the Dresden, but I'm pretty sure they call it Laufs machine because it means running machine. The idea, it's similar to what little kids learn before they start riding a bike, where you have wheels like balance bikes, but you just pedal like the Flintstones. Okay, the idea of human propulsion for these machines is hardly ideal, but eventually we're going to get a rack and pinion thing. Then we're going to get the first one that I think could really be considered a bike. I had a student once who said he was a descendant of Kirkpatrick Macmillan, who developed a pedal drive in 1839. That's 10 years after Stephenson's rocket. It weighed 30 kilograms. Then we're going to go to this guy, Pierre Michaud, and at the 1867 Paris exhibition, he had a bicycle, the Velocipede, the critics called it the Bone Shaker, and he had a factory with 300 workers producing bicycles. This was the first bike that you could actually put an order for, that was actually being sold in large quantities. So that's the one that makes it up on the wall as my innovation on my flashcards. Okay, it's worth pointing out that the development of the bicycle had an effect on gender roles, or not gender roles, but gender norms is probably the word I'm looking for. So Mrs. Amelia Bloomer in America rode around on a bicycle, and it's pretty hard to ride a bicycle in a skirt. It can be done, as we've seen when we see like the Mark Ronson's bike song, the three girls, they're all wearing skirts. But generally, it's much more comfortable to wear pants, I'm told. And so Amelia Bloomer was, her name became associated with bloomers, which are now pants that are worn by women. These days, it tend to be what goes under a skirt. But at the time, the pants that were worn by women were called bloomers, and this had an effect on, this was the sort of the thin edge of the wedge for a lot of feminist causes in terms of gender norms, in terms of clothing, and in terms of sport and accessibility. Like, so, I mean, we still have countries like Saudi Arabia where women have only just been allowed to get driver's licenses, but bicycles pave the way towards more independence for women. So that's a social impact that you could write about if there was ever a question about what are some of the social impacts of bicycles. We're going to find out other social impacts as we go on, don't worry. Okay, so many people are familiar with the penny farthing or the old ordinary. This comes from the term the penny was a coin. The farthing, I believe, is a half. Maybe a farthing is a quarter of a penny, or it might be a half a penny. I don't remember, because I know they have the halfpenny. Anyway, I don't care. We have decimalized currency now, so it's not something I need to commit to memory. The point is, and I'm going to make a bold statement here and say that these things, they were risky. They had good mechanical advantage, but they were risky because they had bad leverage, in the sense that if you broke too suddenly, you could easily go over the handlebars. Whereas when we go into the safety bicycle in 1886, 1885, right, the safety bicycle, when you broke, because you're sitting further back, you can apply your weight more to stop yourself from flying over the handlebars. So you just have a better moment arm. Again, I'm not an expert on these things. I'm taking a shot at it. This is just my very, very rapid interpretation of these notes. By all means, I recommend that you read Copeland's textbook yourself. Okay, so the safety bicycle had a couple of big advantages. So we're going to watch a video now where we're going to compare this vintage bike race. So I'm not going to talk about this, so I'm just going to click through it really quickly. But so this guy here, he has got a safety bike. It's got tube steel. It's got rubber tires. So it's got vulcanized rubber tires which have air blown into them. So it's vulcanized rubber which has this. Did I say sulfur? Sulfur creates cross-linking between the natural rubber chains. So rubber comes from the rubber tree plant. Big thing. The Belgians committed committed atrocities. That's what we're going to use in Belgian Congo because rubber was such a valuable resource. But it wasn't until 1880 the Hitler before Hitler was a guy called Leopold. I want to say Leopold III. It could be Leopold II. Anyway, there's a statue of him. They used to cut off the hands of their slaves to show how many that they'd killed. It's pretty horrific. So if you go to Brussels now, there are statues of someone with a hand cut off. It regularly gets red paint thrown on. Am I going to include this in the recording? We'll see. Anyway, the point is, rubber was once an incredibly valuable resource. Right, and but it wasn't until 1880 when Dunlop came up with a vulcanization process that rubber became a viable option for tires. You fill it with air, it improves the ride quality quite substantially. Okay, so we also could the improvements in steel. So the Bessemer process was developed by Henry Bessemer in 1856. That's behind Luke on our board up there, and the Bessemer process meant that steel suddenly became much more readily available. With steel, we could have tube steel. Now, the problem is you couldn't weld tube steel, not until we get to some alloys. But for the moment, just having steel that you could braze with lugs was a big advantage because it was now much lighter weight. And then the third advantage is you could have it was chain driven. And so these three advantages are going to give us give this rider a big advantage over this bike, which is made out of cast iron, has a solid wheel, and is direct pedaled, right? So there's no chain. Who do you think's going to win? The very fit athlete or this journalist? Journalist is going to win. Okay. It's also worth mentioning, we're going to look at when we see some other aspects in the book, that the brake lining these days, this cable, sorry, not brake lining, this brake linkage is what I'm looking for, the connection from the brakes to the brake handle to the actual brakes themselves, these days is made of stainless steel because it's an area that's very hard to protect from water. So you can use a plastic sheath, but even then, any water that gets in there is going to cause corrosion. Brakes failing is really dangerous. So it's really important that we do whatever we can to protect that brake linkage. And the handle, the part that you actually press, is often made out of aluminium because it's light and corrosion resistant. Okay, so we're going to see him ride, and ready, set, go. So he's riding pretty slowly. He's like, oh, he's got it now. He's really going. He's really cooking. Whereas on the other hand, the journalist, he's just zooming along, right? As we go through, we see he's able to catch the very fit cyclist. Okay, that will do for that. So, 1866, the Rover safety bike. Okay, mass production. So by the time we get to the early 20th century, we start to see a much more widespread use of bicycles. Being mass produced by 300 separate components. Part of that would have been influenced by the Model T. So we've got the Model T above Nick. The production line led to reduction in production times, and as a result, a reduction in costs. So, so we've got some famous companies. So Morris and Peugeot being early mass producers of bicycles. Okay, so we're looking at modern bicycles. So up to today, what are we looking at? So we've got the derailleur as a on the chains. I don't really know much about chains, so I'm going to move on so I don't embarrass myself on the internet. Mountain bikes are more heavy duty than road bikes. So these days we see a differentiation because we don't have a general all-purpose bike. People rather buy a bike depending on the style of transport they want. So a mountain bike has thicker wheels, and a more sturdy frame, the classic diamond frame, whereas a racing bike will have a lighter weight frame with thin, narrower wheels, but it will have, it trades that stability or that durability for speed. It's also worth mentioning that BMX, so both bicycle motocross, has another different type of handlebar, which is mainly used to really punish the bike so that you can do tricks and things like that. Okay, road bicycles. Now we have Molten bikes. Molten bikes are folding. Somewhere in here, Copeland also talks about recumbent bikes. They're the bicycles that they're like, I think they usually, I think they have to have at least 3 wheels, where you lay down flat. And if you live in the Shire, you might even see Copeland riding around. So be sure to say hello. I did tell him that, you know, I'd mentioned that, so be sure to say hello. Okay, so Molten bikes, one of the advantages of folding bikes, I have a folding e-bike. One of the advantages of folding e-bikes is you can chuck them in the back of your car, right? You don't need a special, you don't need to have a bike frame to put it on. But one of the things is if you take them on the train, you don't have to have a ticket for a folding bike. Whereas if you take a bike on the train during peak hour, you have to have a separate ticket for the bike. Okay. So then we talk about car propulsion. So basically Copeland says when he first wrote this book, hybrids seemed a bit like a pipe dream. You didn't think that they were realistic. Well, it seemed like they were a long way away. Whereas these days, most manufacturers are working at least towards hybrid cars, and if not fully electric vehicles. The first car to require fully electric vehicles is Norway. So in 2035, which is 9 years from when not 9 and a bit years from when I'm recording this, you will no longer be able to buy a car that burns petrol. So I've got Lachlan Cole, who's confused about the maths there. Yeah. Okay. So look, we're just going to say, what did I say?
You said 9 years from.
Oh, okay. Oh, sorry. Okay. So I think I was meant to say 11 and a half years, but yes. Okay. Sorry for that. But thank you for bringing that to my attention. Thanks, Archer, for the hand gestures. Okay. So we're now going to move on to trains. So there are lots of different trains in this book. So first of all, the first trains, the first things that ran on rail were carriages that were being pulled by donkeys, mules, pit ponies, right? The reason you have rail is because if you have a mine and it gets washed out, well, the wheel could get bogged into the mud. And if the wheel gets bogged into the mud, you have to pull a lot harder. The mule is going to have to pull a lot harder to get that wheel stuck in the mud. And mules, they can only pull so many tons of coal before, you know, they can't pull no more. And then anyone who's read Animal Farm knows that, you know, it's not a good ending for those equines that have reached the end of their life. So by putting it on rails instead, the ponies could pull more coal, and, you know, it's a longer time before they get sent to the knackers. So that's where we first see the use of rail. We're going to talk about gauge at a later point, but we'll say that the standard gauge is developed by the width of a pony, right, or the width of a horse. So carriages have been used for a long time. Those carriages, so the Romans had wheels with carriages. Those carriages are usually determined by the width of the horse that's pulling them. So you have these ruts that travel along roads all over Europe. And when it came time to choose a gauge, they're like, well, we'll just make it the same width as the ruts that are already in the road. Some people tried some fancy things, and when I talk extensively about 18xx games later, I'll talk about the 3 games that have multiple gauges. 2 of them have dual gauge, and then 1 of them has triple gauge. We'll talk about that in a second. But will I show them in the video? Probably not, because it just takes too long for me to look them up. Then we're going to have steam trains. So Richard Trevicek, so there's a famous Polish designer called Ignacy Trevicek. He works at the Coalbrookdale Ironworks. So remember how Coalbrookdale was this center of production. So Abraham Darby, he was the first person to mass produce things using cast iron. His grandson built the first iron bridge. And this is why if you play the board game Brass, now it was briefly #1 on the top of Board Game Geek and my favorite game. One of the cities you can go to, one of the cities you can build from is Coalbrookdale, because that's in that area. So he built a steam locomotive. which is why somewhere along here I do have Kylie Minogue's. I'm probably getting a copy struck for having her. I didn't even get the chorus where she says, "Come on, do the locomotion with me." Anyway, you got to swing your hips now. So back to the book. So locomotion just being Latin for movement. George Stephenson, he was a mine mechanic, and in 1814 he started developing some trains. Eventually we got to trains that went 16 kilometers. I'm like, oh, there we go. He named it the locomotion. Do I consider this train to be the first train? I do not. I do not consider it to be the first train. Right, 16 Ks, that's not a railway. Right, so I don't consider anything short of the first 18XX game, 1829, right? I refuse to buy any 18XX game that's set before 1829. So 1812, popular 18XX game, refuse to play it because, you can't have trains before 1829. Anyway, so there is a board game called Stephenson's Rockets by Rainer Knizia. It's okay. It's I think it's a 7, and I've said on record, I'm on record saying that life is too short to play 7s. But Stephenson's Rocket, it's okay. But the Rockets, it could go 46 k's an hour, and it was part of an actual public rail network. So that was developed by Robert Stephenson, not George Stephenson. Robert Stephenson, we saw previously in the civil chapter, he invented the bowstring girder. Sorry, the bowstring bridge, not bowstring girder. I don't know why I said that. Anyway, I feel like an idiot now, but I'm just sticking with it. Okay, so the rocket was twice as fast as its rivals. It could pull 14 tons at 46 k's an hour. It was just a innovation, right? So much so that he is featured. There is a steam engine in Thomas. Look at that rocket, right? The first time I saw, I don't know when he first appeared, in which episode, but when I was watching the TV once and I saw, oh, there you go, first appearances in 2013. How many years ago was that? 10, thanks, Archer. 10 years ago, Stephen first appeared on Thomas the Tank Engine, and I was so excited, I took a photo and posted it to my class because I was just giddy with excitement that it was Stephenson's rocket. Anyway, so what are we looking at? We're looking at here. Okay, so Stephenson's rocket is what I think is, if I asked you to name an important innovation in the development of trains, I would write Stephenson's rocket, developed in 1929, was a innovation in that it was twice as fast as other trains at the time. Okay, why is it called a rocket? There were no spaceships at the time. Why would they call it a rocket? Chinese fireworks, thanks. Okay, so another big innovation was in 76, but that was a compounding steam engine. No, sorry, what did it use? I will be honest, I haven't memorized any of these things. But I do know that they should have a picture later of the compounding steam engine. I don't really care too much about these things. I think you're very unlikely to have these questions come up. Okay, so then we have trains, the carriage, right? So if anyone's a Thomas fan, Annabelle and Clarabelle, sorry, is it Annie and Clarabelle? I think it was Annie and Clarabelle. They could go up a grade of 1 in 6, which is pretty steep, whereas the trains themselves couldn't go up more than 1 in 25. There's a movie called Under the Tuscan Sun where she's building this house in Italy, and then she starts to have like a bit of a crisis, right? Well, that's the word I'm going to use, a crisis. And the builder says, let me tell you this story. Once upon a time, there was a train that they built a train line through the mountains. And when they did, there wasn't a train that was strong enough to pull the train, to go up the track. But you know what? They built it anyway because they knew one day the train would come. And of course, by the end of the movie, the house is filled with people, and it's not her family, but it's an extended family, including the builder, and they're all there, and she's really glad that she went ahead with the project. Anyways, that's a bit of a spoiler for, a movie from 20 years ago that I don't think any of you were likely to watch. You can see that clip. It's on YouTube somewhere. Okay, so Richard Hammond has a video about trains and how they struggle to go up grades, and they talk about like why don't they slip and all those sorts of things. So remind me, and I'll find a link for both of those things. Okay, I'm going to move on because I don't have much time and I want to try and get this done in one session. And I am going to say that when we start talking about Australian locomotives, 4 Shay locomotives were used in New South Wales. Mostly in the 1910s. Okay, gauge. This is what I want to talk about. So, there are some 18XX games. So there's the one set in Sicily. I don't think that's 1888 or 1889. It could be, though. I think that might be the Japanese one. Anyway, the game of Sicilian Railways is what it's called. We're going to look it up. We are. 1849. I was way off. Anyway, so that has dual gauge. The first one to have dual gauge I have over there, it's 1853. That's it in India. The reason why they have dual gauge in 1853 So in 1853 they have dual gauge. The reason they have dual gauge is they have 2 different kinds of tracks. So this here, they're using the different side of the tiles, but they're using the black gauge, which is narrow gauge. So narrow gauge is good for this is meter gauge, right? It's good for the mountains, right? And then they have wide track, right, which is useful because it has better turning, right? So if you have narrow gauge, the risk is that the train is more likely to derail. So then we have Australia. So 18. What's Australia? Can anyone see? It's over there. 1848, I think.
Yep, 48.
Okay, it's got 3 gauges because 2 gauges is not enough, right? So what happened is that New South Wales, they went with standard gauge, right? The one determined by the horse's rear end, whereas so we went with the standard gauge, and then Victoria. Yeah, so there's some evidence that the strange size dates back to Roman chariots. I think I may mention that, like, the design of the space shuttle has a link back to these Roman horses because that space shuttle was delivered on railway. The railways delivered on tracks that had standard gauge, and that determined how big the thing could be. Anyway, so all railway engineers simply use this accepted gauge, except for Brunel. We talked about Brunel. Brunel built a lot of bridges. He also built the Great Eastern, and I think he also built the Thames Tunnel. Maybe, anyway, so he's a really famous engineer. Anyway, so, there we go. We discussed Brunel's bridge designs in Chapter 1. Here's, okay, so he set up the Great Western Railway, and he felt as though 6 feet was a much better size. So he, and he was right. Wider gauges make the train more stable and less likely to roll. However, it does make tight curves even more difficult. So there you go. Unfortunately, he was the only person to adopt this gauge. And then other people set up their other gauges. So there's an XKCD where they talk about how there are too many standards. What we should do is develop a new standard that includes all the previous standards. Now there's 12 standards. Now there's 13 standards. Anyway, I didn't deliver that joke well. Anyway, so New South Wales used standard gauge. Victoria used not even Brunel's gauge. They just picked a slightly wider gauge. And then Queensland used a narrow, not quite meter gauge. Right, so in India they used meter gauge through mountains. The benefit of using meter gauge is it's a lot easier to cut through a mountain when you only have to cut through 1 meter rather than 1.5 meters. Okay, eventually the madness stopped when Victoria and Queensland figured out that New South Wales was right all along. Okay, electric trains. The big advantage of electric trains is that they are less polluting. Now, what that means is that they do not blow a whole bunch of smoke where the passengers are standing in the tunnel. Right? That's a big advantage of electric trains. That doesn't mean that they don't rely on fossil fuels. In New South Wales, trains run on electricity. Electricity in New South Wales is generated by burning coal. Coal is a polluting, non-renewable resource that contributes to climate change. However, it is way more efficient to produce your electricity to produce electricity through the thermal of coal in a power plant than it is to burn coal in the boiler of each individual train, right? You can't make a machine efficient when it's only the size of a train. You can make a machine very efficient when it's the size of a school. Yeah, so that's why you can even introduce things like carbon capture and storage, where some coal plants actually capture the carbon dioxide they emit and then they store it underground. Okay. The disadvantage of electricity, though, is you need infrastructure. So the infrastructure is you need overhead wiring, or you need, what's the alternative to overhead wiring?
Wiring to go underneath.
Yeah, so that's called third rail, right? So I won't go into too much detail, but we can use overhead wiring or we can use third rail. So the connection is through something called a pantograph. That's that the thing that sits on top of the train. Okay, so a pantograph, which comes from this kind of drawing thing, but so it can move to be in contact with the contact wire, or we can have third rail. Now the downside of third rail is it's much easier to touch the rail when it's on the ground than when it's in the air. You have to have a pretty good vertical leap to be able to touch the contact wire on overhead wiring. You don't need to have a great vertical leap to be able to go down on the track and just touch the third rail. Also, even if you do have a good vertical leap, you're going to be in the air when you're touching that wire, so the electricity is just going to continue to flow through the wire because you have more resistance than the wire does, right? On the other hand, when you connect the third rail to the ground, well, now the electricity can choose that it can go all the way through the circuit, or it could just go into the ground via you. You are a lot closer, and even though you might have a much higher resistance, the total energy or the potential difference makes going through you a pretty viable option. If you look, you used to be able to see videos on the internet of people touching contact wires while standing on trains. It did not end well for these people. I think these days those sorts of things get taken off the internet. I lived in a different time, you know, when I was your age. There was a lot more things on the internet. I don't know, maybe it was now just all in a different part of the internet. Okay, so first electric trains were demonstrated in Berlin a long time ago. Like, when I say a long time ago, I mean, you know, not long after the development of trains. However, we didn't see first electric underground was in 1890. That's not long after. So the tube, as it's called in England. Okay, so we saw electrification in 1926 in between Museum and St James stations, and then other stations soon followed. He says electric trains do not stop pollution. Okay, so diesel is the true successor to steam, can be run along steam trains. The great advantage of diesel is you don't need to have overhead wiring. You don't need to build all the infrastructure. Overhead wiring or third rail, whatever you're going to build, is only really makes sense in metro areas. So when you have a freight train that's running from Sydney to Melbourne, you can't. No one's going to build all that overhead wiring for like hundreds of kilometers where there's no stop. So instead, what we're going to run on these days is we're going to run on diesels. In all these 18XX games, usually the best trains you buy are the diesels, right? I think in Steam Over Holland, which doesn't have 18 in its name, I think they have electric. The E trains are the best ones, but most of the time diesels, like in 1830, diesels are the thing we want to get to. Okay, so what diesels do, typically the first diesel, but future diesel trains lay in diesel-electric arrangement. This is where the diesel generator so your diesel engine drives a large generator and the electricity drives an electric motor with you. This is because it has a much better much better system than a gearbox, I should say, for power delivery. So this is how we get that traction that Richard Hammond talks about in his video. The same thing is true of Teslas, right? Teslas can go from 0 to 100 in a very short time. They've got excellent grunt. This is where the shunt DC motors are really important, because when you're pulling a 400-ton train, you really need something that can get that initial movement. And it's very difficult to get that initial movement with a petrol engine or a diesel engine. Okay, by the 1960s, New South Wales diesels had become widespread, and by the 1970s, steam was gone. These days, if you take an XPT train between Sydney and Melbourne, it will probably be diesel. It will be diesel. Same with the Indian Pacific and the Ghan. Okay. Yeah. Okay. So there's a series of dot points that you can go through, and I ask people to usually write that a summary of these dot points in their notes for homework. We're going to talk very, very briefly about materials. So timber. The things that go on the ground that join the two rails are called sleepers in Australia and ties in America. So if you're a fan of the right-wing conservative favorite Ayn Rand, she has a book about trains called Atlas Shrugged. I read it because, you know, I worked on trains. They call it train ties, and I didn't know what that was. Anyway, once upon a time, you'd cut down old trees, right? And old hardwood trees would be what you'd use for sleepers. These days, there's not many old hardwood trees around, so instead what you use is concrete sleepers. Once upon a time, they used to be held in place by spikes. There's a company that makes 18xx games is called Golden Spike Games, but usually where the two halves, like so for instance when the Trans-American Railway was built, the spike that joined the east and west halves is usually a golden spike where you write the date and who drove it. Anyway, these days you don't use spikes, you use pandrel clips, which are better for thermal expansion. They allow for more movement and all that sort of stuff. Yeah, I'm going to move on. Okay, so iron. Iron was initially used as a tire on wooden wheels for early frames, so we saw that bike. It was replaced by steel frames and then by rubber tires, but specifically vulcanized rubber developed by Dunlop in 1880, which has sulfur, which creates cross-linking. Okay, after Henry Bessemer developed his process in 1856, steel became more widely used. Steel tubing offered good strength with relatively low weight. Coal-drawn steel tubes offered the best strength for cycle frames. They had to be joined by brazing lugs. You couldn't weld them, but later we were able to weld them. Okay, alloy steels, specifically these manganese molybdenum steels, offered a better strength to weight ratio, and they were used. Then we had chromo bikes. Chromo bikes are good because you could weld them, right? They could. The advantage of TIG and MIG welded frames were they were quicker and lighter and cheaper to fabricate than brazed steel lugs. This is why I have my picture of ScoMo, not ScoMo, more like chromo,
so the
right?
ceremony to commemorate the 80th.
This is ScoMo trying to weld, but then he got, gave a whole bunch of photographers archive because he, didn't, he welded when he wasn't supposed to. Anyway, that was news once. ScoMo was a politician. He was Prime Minister of Australia. Anyway, so then we moved on to stainless steels. So they offer about 4 times the UTS. We're not usually interested in UTS. Remember, we're typically interested in the yield strength, but still substantially stronger than mild steel. They also have better corrosion resistance. One of the places we see is they're used in in the manufacture of the bike cables, sorry, the brake cables. So why? Because they're an area that is very important, right? We don't want to have brakes fail, and also they're very hard to protect from corrosion with, say, a coating. Aluminium bikes, specifically the 6000 and 7000 series, can be heat treated, precipitation hardened. You might remember we talked about precipitation hardening back when we were doing stainless steel at the end, when we were doing biomedical. But we only touch on it very briefly. We're going to touch on it in a lot more detail later on when we talk about aluminium. So there are 3 kinds of aluminium that can be heat treated: the 6, the 7, and the 2000 series. I should have said 267. Anyway, I have a way of remembering all of the different kinds of aluminium, but let's just say that they can be welded using mostly TIG, but sometimes MIG welding. They're light and corrosion resistant. Titanium was seemed to offer a lightweight and more corrosion resistant option for the same strength. However, it soon got supplanted by carbon fiber reinforced polymer, which has excellent strength to weight ratio, great corrosion resistance. The biggest problem with it, though, is it fails catastrophically. It's a brittle material that doesn't give you any warning that it's going to fail. Rubber, we talked about Dunlop. Oh man, it was Dunlop in 1888, not 1880. I think I just, you'll have to ignore when I said 1880 all those times. Anyway, the pneumatic tire. Today, synthetic rubber is still used. Yep. All those tires that on the cars that you probably came to school in. Okay, polymers are used. An example is the sheath that go over the cables, the brake cables we talked about earlier. They offer flexibility, lightweight. They have good resistance to degradation from UV light. Okay, so the environmental effects. It's worth mentioning that bicycles definitely have an environmental impact, right? In places like Amsterdam, where there's just hundreds of bikes that get chained to bridges every year that just start rusting away, that they use steel. Steel is a non-renewable resource. There's only a finite amount of steel. When we run out for good. However, steel is recyclable, and that's good. There is some energy consumption when we recycle, right? And whenever we recycle anything, there's going to be some amount of energy that's used. Nevertheless, bicycles do not require fossil fuels to operate. They don't even require electricity to operate. Thus, they are very, very fuel efficient. So they're very environmentally friendly in their operation. It goes without saying, I think most people are pretty familiar with the idea that using a bike is better for the environment than using a car, right? So although there are some, you can say, oh, but your bike is made out of steel. It's like, yep, you got me. Yep, that's true. But there's no one can dispute that bikes are definitely better comparatively, they are better than cars in the environment. Trains are also good for the environment. Okay, steam trains were only about 5 or 10% efficient, whereas modern trains are substantially higher. We talked about how electric trains running in New South Wales still burn coal. They just don't burn coal at the train station, which is great because when I'm standing on Town Hall Station, I'm not breathing in a whole bunch of coal, right? Where instead that pollution, that carbon dioxide, is being produced in power plants, which are much more regulated and they have much more efficient. Okay. Okay, forests. The building of all of those railway sleepers chopped down a lot of old growth forests. Those forests are gone. They're pretty much never going to be replaced. Steel, right? Again, we mentioned Bessemer process. So steel. So Port Kembla down near Wollongong used to have a famous steel works, but it's not just about where the steel comes from. It's not just where the ore comes from. It also matters where the limestone comes from and where the coal comes from. Right, this is why BHP has a big presence in Newcastle, because that's where all the coal is. Right, Port Kembla, I believe that it's actually not so much that they have abundance of ore, like Broken Hill has an abundance of ore. It's that it has an abundance of limestone, because you have to ship a lot of limestone to make steel. To be specific, you don't actually use coal; you use coke. Yeah, coke is a type of coal, a refined coal. Okay. If you play the game Le Havre, you use coke. Cast iron has a similar impact to steel, but it's used a lot less. We now only really use it for things like, engine blocks and brake pads, that sort of stuff. Okay, aluminium. Aluminium uses an incredible amount of electricity. So again, you have to mine the ore, the bauxite ore, but it uses an incredible amount of electricity. I believe that aluminium is the primary use of, it's the #1 use of electricity in South Australia. Polymers. Polymers are made from crude oil. They're a fossil fuel product. And one day, future humans are going to look back and say, I can't believe you took this valuable crude oil that there's a finite amount and you burnt it to keep yourself warm. It's incredible that we burn polymers, these very, very, very valuable materials we burn fossil fuels to keep ourselves warm. We burn fossil fuels to power cars when we don't need to. Whereas we really need polymers. Like if you just use the medical industry, remember we did biomedical innovations, that we need blood bags, right, which are made out of PVC. We need things like AngioFlex for artificial hearts. We really do need surgical gloves and ways that we can sterilize keep our needles, so when you open a needle, that it's sterile, right? So that's it. It'd be very difficult to replace all polymers, and there's a finite amount, and when we use it, it's gone forever, right? This is the biggest reason why we should be moving away from using burning fossil fuels, because future generations are going to want to have polymers. Instead, 50% of our polymer use is making water bottles. That's a number I just made up, and probably not even true because that's PET. We know that the most commonly used polymer is number 2, polyethylene. Nevertheless, right? Polymers are really important. Okay, I think we got that all done pretty much in a lesson. So, well done, everybody.